for this morning sessions, hopefully it is very big day, and then also you can see what will be coming for this workshop. So the first day, it's more or less on how big data and also data science are related. So more introduction of data science, and we will give some example of our implementation of utilizing big data for official statistics by my colleague Diarnik and Larasati. I skipped this. It's already mentioned by Paeka. So I'm pretty sure all the participants have experience or have heard about the big data quote unquote terminology, right? And then there's some feedback here. Could you please? Okay, thank you. So big data, we have some fees that 8 fees, value, veracity, and etc. But actually, this is the idea of, based on ITU, big data is a paradigm for enabling the collection, storage, management, and analysis, and also visualization, and hopefully, we expect under real-time constraint with different characteristics and heterogeneous characteristics or type of data. That's type of big data. So when we see big data, it's not about only the volume itself, but also related to different type, variety of the data. It could be structured data and also unstructured data. I'm sure that for all of us come from National Statistics Office of our country, we are already experienced with structured data. But now the technology have increased rapidly, and we now deal not only on structured data, but also unstructured data. So the activity of the big data will be related to capturing, storing, processing, sharing, and reporting. And this, as I mentioned before, this is above or beyond the ability of previous software tools that have been known in a couple of years before. And the thing is that when we see big data, it's not only one type of field that are working on this type. Usually we learn about statistics, right? Only statistics. But now we have what's so-called data science field, which actually a combination of several fields, let's say from statistics, data analytics, and then computer science, and then other things, which will make a term of data science. And then inside this data science, we will have some machine learning process, and also possible of artificial intelligence, and also IoT, and also other technology. And the expectation of this big data, we have to have efficient and cost-effective, and also faster and accurate decision making. So this is actually the main goal. When we have big data, but we just produce a publication of our national statistic 2 years or 1 month, but with data, that's not the big data, just like ordinary or conventional statistics, right? We expect that by having this big data, we can have a faster, efficient, cost-effective, and accurate data, so we can give accurate and faster decision making. So of course, the big data will see that the number in the table left hand side, you see that some gigabyte, terabyte, petabyte, and zettabyte data. There are some zeros over there. The next slide I will explain. I will briefly overview or visualize how big is that. But as comparison of the big data in 1990, that we usually store above like 1 gig is already big, right? And then the transfer speed is only 4.5 megabyte per second, and read drive is about 5 minutes. And 2010 storage up to 1 terabyte, and the speed is up to 100 megabyte. But now the technology and also the demand is getting higher and faster. So with the Hadoop, we can have hundreds of drives working at the same time within minutes. So how large is big? So maybe there are some question on how big. So for illustration, if you have 1 grain is 1 byte of data, so 1 kilobyte is 1 cup of rice, and then we have 1 megabyte is 8 bags of rice, right? If we have 1 terabyte is similar with 2 container of ships. One ship already blocking Suez Canal. That's a problem, right? This is already 2 container ships, and then 1 petabyte. All the grain of rice will cover Manhattan, right? That's how to illustrate the size of the data and how this data can have a problem if we don't handle it carefully and also effectively. So this is for main phase of big data, the volume. So the volume, this because of the volume of the data so high, because of the streaming of the data, so the velocity, the generation of the data, there's some data coming for milliseconds and days, yeah, and then hourly, right? So for example, events on speech or social media or other information that come from sensors. And the variety of data comes from it could be like structure. We expect we know the table, the one of structures, and structure from text, for example, from videos, from speech, and for other type of data. And then the veracity. This is the main things I think I have to bold because we are working now. We are more all of us in national statistics, which have to provide valid information, right? So though we have a large number of data, large variety of data, and then the velocity of data is very, very fast, but the main things we have to make sure of the data that we can get actually can be trusted, because only few of the data can be trusted because of some maybe it's not based on the true. It could be some misleading. There's some fraud related to propaganda and etc. So these are the main characteristic of big data. So this is several type of big data sources. There are 3 types: exhaust data, sensing data, and digital content. So exhaust data comes from digital activities of people, for example, mobile phone data, financial transaction, online search, and also our postal data. And we have also sensing data. The data comes from sensor, comes from medical devices, come from tools, come from other device, for example, biometric data, Internet of Things, connection of the things that are connected to internet, sensors, and satellite imagery, and other example of the sensing data. And the other type of data sources is digital content. This comes from information posted in the website, right? For example, social media, web scraping. We will more on the web scraping discussion during this workshop. Participatory sensing, which is crowdsourcing. We get data from information from the crowd, from people, health record, radio content, and etc. So the first 2 data sources, exhaust data and sensing data, they are measuring what people do. So this mobile data, how people are moving around, what they are talking about, if we can get the content, and how the transaction based on the financial transaction. That's what people do. The same thing with sensing data, biometric data. If you know now, because of COVID, we heard more on PCR or NGS, next generation sequencing, which actually the size of the data is so high, also so big, that measuring what is happening inside the body. So that's what people do, right? Moving around or moving something, for example, sensors of flights, and also sensor of buses, etc. And then the digital content, this type of data sources, this measuring what people say or what people think in mind. The difference, the veracity of digital content is very low, right? The quality or the truthness of the digital content should be considered carefully, because it could be propaganda, it could be deceptive, right? It could be that not correct one. So we need really to be careful to take care of the digital content data. So all the data that we have, we plan to do the analytics approaches, right? So this is the step of the analytic approaches. We start with descriptive approach. So we try to understand what is happening, or what happened in the past, or what is happening right now. That's descriptive. And then once we know what is happening, we try to go further than doing what is happening. Why it's happening right now? So why did it happen? That's a diagnostic approach. And then the next step is to have some predictive. What will happen? And what will happen under various conditions? We try to give some different conditions. Maybe we can predict what we expected outcome of this condition. And then the ultimate analytic approach, which actually we need to go from descriptive, diagnostic, and predictive, is to prescribe. So to give information, or to try to give or to provide what type of options to create the optimal or the high result of outcome. So this is a kind of correlation or association between big data and data science, right? So in big data, we have quite a amount of data, and then we don't worry again about the number of data, because data is there everywhere. The structure is quite diverse, and the volume and also the speed is very fast. But then we need to make this data into information, right? So the analytics come for this part. So the analytic is related to how to discover, to interpret, and to communicate the information and the patterns that from the data. So this process include uncovering the hidden patterns, and try to understand unknown correlations, and then to extract other useful information that maybe we expect can help organization. In our case, it could be government or a citizen for their decisions, right? So the activity is of this data analytics is mentioned by data science, so try to extract information and knowledge, and then this combination between math and statistics, and also information system, IT, business case, and etc. And big data can be very fast, complex, and also the information quite diverse, from CCTV, vlog, it could be podcast, it could be TikTok, it could be other things, historical data combined with our official data. That will be good for having a more deep and also more high quality of data analytics. And then related to, we can also have some social computing, quantification of social and human behavior. For example, for market segmentations and fraud detection and purchase behavior, and also brand awareness, and etc. So this is the hierarchy of data science. So we start with data collections, which include the instrumentation development, a sensor providing, getting the data, and also user-generated content. And this is usually developed by software engineer. And then the next step is to collect the data and to store the data. And this is usually done by data engineers to make sure there are some good, reliable data flow from the data, and also the storage, the place, and then make sure the infrastructure are running well, and also can be streamed daily or weekly, or cannot be stopped, and to make sure the storage of unstructured and structured data nicely, and provide ETL, extraction, transformation, loading to the next step is to cleaning, and also to find the anomaly detection, to find some anomaly from the data. There's some maybe some hoax from the data. That's including the pre-processing step. So all the steps usually is done or is responsible of data engineers. For the data engineer stream, more you will focus on these two or from the data collection steps, and then after data is being processed. And for your information, the first and the second up to the third step exploration is maybe 70 to 80% of the total work of the data. So actually this step is really laborious and then need to be carefully done. Otherwise, we'll end up with very bad quality of data. And once we have good data or all process data, we next to do the analytics and some aggregation and feature selection, and then some simple machine learning algorithms that being done by data science analytics. There are some cases that include the AI and deep learning, which usually performed by research scientists. Usually is done by student of or for Ph.D. Level case for developing AI and deep learning in advanced analysis. So the different of data engineer and data scientists, and there are some as I mentioned, and then these are some languages, tools, and software by for example, for data engineers you have MongoDB, Postgre, Hive, and then in between the connection between the data engineer and also data scientist will be you have Hadoop, Spark, and other platform that will be discussed by our colleague from data engineer team. For data scientists, these are some tools and software that usually being used, for example, Tableau, Pandas from Python, SAS or R, Python, right? GameP, that's for social media, RapidMiner, Excel, of course, or ggplot for MATLAB. But for us, for this workshop, we'll more focus on Python. Of course, we cannot do also for R, but if we do both, it will be confusing. So for this workshop, we'll use a Python, and then Pandas will be discussed next tomorrow or the day after tomorrow, and also some of Matplotlib for visualizations. And then for the second part will be we'll discuss Tableau for visualization and also Power BI for visualizations. And for data engineer will be also discuss on Hadoop, Spark, and etc. from data engineer workshop. So this is the criteria of big data team. So of course, if you look at these, the criteria is quite challenging to find this type of people. And if we have that of people, I'm sure they will prefer to work on the business or they prefer to work on the private companies, because now the salary of data engineer and data scientist is quite high. So to have this team, of course, there are some essential program and technical skills that are needed. You can see this start from data engineer, Apache, Hadoop, and Amazon service, Azure, etc. Of course, we also need a technical skill, SQL, and also ETL group tools, machine learning, Python, and also some knowledge of algorithm and data structures. But we also need soft skill to communicate this information, to communicate the data, the system, and to collaborate with data scientist team, data analysis team, and also to present all the information to the stakeholders. Similar with data scientists, the essential programs need to be obtained by data scientists is Python and R, for example, and also SQL, and also some machine learning and AI procedure. Same is to visualize and also business strategy and machine learning and AI. Not only communication and collaborations, The challenge of data scientists is to make sure the data and the information has been resulted through all the laborious process can be explained to the users, right? So skill of storytelling and learning new thing is important for data scientists. This is the body of knowledge of data science. We have data analytics, data management, data engineering, business analytics, and research methods, and project management. We focus only on data analytics and data engineer for this. So data analytics consists of machine learning knowledge we need to know, and data mining, statistical methods, computational modeling, simulation, text mining, graph analysis, and also business analytics. If you look at all these knowledge that need to be or we expect to have for data scientists is quite diverse and quite hard. Understanding statistical method is quite challenging. Having or adding data mining and some machine learning, that's another level of challenging approach. But those information need to be acquired by data scientist team. I said team, why? Because I'm sure that not all of us can understand all this information. In BPS, for example, usually that text mining, we have a group of team that focus on text mining, and another one is on graph analytics, and some people are focused on statistical method, and we have research group on machine learning and data mining. And usually we collaborate with other division on business analytics related to some modeling. That's another statistics and also methodology department of that. So data science is not only 1 or 2% knowing or understanding all this information, but instead this is a team that can collaborate together and they know all these informations. And this is the data engineer knowledge, including the big data system, organization engineering, infrastructure and platforms, big data infrastructure and technology, and then data and application security, because we have all the data comes, and then to make sure the security and confidentiality are kept. And then the cloud computing technology for big data and data analysis, because for information, most of the large company that working on big data, they don't use on-premise infrastructures for their computing technology. Usually they use a platform, a cloud platform, because it's easy to use and then can be implemented easily, and then it's perform well, and then we don't need to it's quite cheap as compared to on-premise, but then that depends on the situation of the companies. And also data science apps design, and then information system to support driven decision system. So this the big data related technology and also methodology, artificial intelligence. For the last part of data science, we will discuss on simple machine learning. It could be unsupervised and supervised learning, and then that's simple data mining. But all this information need to be acquired by data science teams. It could be not only one person, but it could be one team working on data mining. Another team is on social media analytics, and another one is on video or text analytics. This is example of artificial intelligence. We have deduction, resonance, so knowledge representation, planning. For the last part, we'll focus on machine learning. As I mentioned, we'll discuss on supervised learning and supervised learning. Reinforcement learning, we're not going to discuss that, but if any question that we also can give that. But supervised learning, including decision tree, association rule. For unsupervised learning, including clusterings, and also similar and metric learning that will be given on the last part of the workshop, part 3. Then we have the data, right? We have the technology there, but then this is the main challenges of the data. First is to access the data access. Not all the data can be accessed easily, not all as mentioned, because the data now is being they are being owned. They are owned by private company. For example, data of marketplace, data of Uber, for example, travel agencies that owned by companies, right? So we need to have some discussion or collaborations with them to get access. And then the second is data privacy, right? So the privacy, because we get mobile phone example, we get the mobility of this person, how to make sure this data cannot be reveal the person activities, one person activities. And then the next challenges is to find the best and also suitable algorithm based on the characteristics. When I say algorithms, it's not only focused on the quality and also the accuracy, because all the data, this is threshold. There are some threshold within data accuracy and also the speed of the analysis. Usually we want to have accuracy, but takes time of having that. And also we have to find the evaluation, and also we have to find the best algorithm of different type of data. And then, as I mentioned, speed and accuracy. And then to find the scientific equations and also the hypothesis. And the challenge is to find how to make sure the data comes really fast and also in the nice way, streaming data online. That's also another challenge. You have the data comes weekly. That's not that fast. It could be daily, it could be hourly, and then we can provide the analytics in real time as well. That's maybe that's not that common in conventional statistic. Usually we get from sample from information from field, right? And we do some data analytics, and then we publish it during a couple of weeks or months after the samples. We don't do real-time analytics. But right now, with all the data, we have to go to real-time analytics. We don't need to wait for 1 or 2 months. We expect to get information within within days, so we can also provide the data in real time. And the challenge is data quality, right? Because the data comes, they consist of unclean data, they consist of information that not correct, and then we have to make sure the information, the quality from the data can be accessed and can be obtained. The difference between the conventional or previously approach data quality, usually we will make sure the data obtain similar what we expect, or the questionnaire and also the way we ask is good, right? But then now the data comes with their problem. We have to split, we have to clean up all the problem after data comes to us. That's challenges that we have been faced for couple of years when we do this big data analytics in BPS. And then the last challenge, which is actually the main problem, I'm not sure, I'm pretty sure for all the ASEAN countries, is too hard to find the right talent. It's not only for a national statistics office, but it's also for business and also for private companies. They always discuss with us, with me as well as privately, how to find the right talent, because knowing all this information is another challenge, and to find the right talent, the right person to understand and can run and also can do all this hard and also fast analysis is difficult to find. Right now, there are some universities that changing they're adopting their syllabus. For example, political statistics, we have data science program, and also there are some university in Indonesia, and also I think Malaysia, and also Singapore, and also other ASEAN countries have a university that already adopting data science syllabus and changing from data science, from statistics to data science, or from IT to data science department.